present is the lignin. So lignin is a highly cross-linked polymer with a three-dimensional structure, which is having phenol units. So these phenol units are joined together by intermolecular hydrogen bonding. So hardwood lignin contains mainly coniferyl, synapyl based alcohols, whereas softwood lignin contains mainly coniferyl alcohol with a little para-coumaryl alcohol. So these are the components are present in the lignin as monomeric units. Here clearly represented, lignin contains monomeric units are para-coumaryl alcohol, coniferyl alcohol, synapyl alcohol. So these are the monomeric units are present in the lignin. So next, the precursors are present in the lignin are hydroxyphenyl, VACL, and serengyl units. Next, from these, what are the phenoxyl radicals generated from these three monolignins are randomly polymerized. So that means in the biosynthesis process, so the precursors are generated, that means the para-coumaryl alcohol, coniferyl alcohol, synapyl alcohol, from which the phenoxy radicals are generated according to the mechanism, and they polymerize to form the three-dimensional network of the lignin. So these monomeric units are joined by the linkages that are found here is the beta. B means here beta oxygen 4, beta oxygen 5, beta 5 linkages, and 5 oxygen 4 linkages. Here the main thing you can observe the monolignins, generic lignin units, and hydroxycernamates. So in realistic, the monolignons are present as the para-coumaryl alcohol, coniferyl alcohol, and synapyl alcohol. So these three are the monomeric units are present in the lignin. So those are actually present in the lignin in the polymerization process. That means generic lignin units are para-hydroxyphenyl unit, VACL units, and a serengyl unit. Next, hydroxycernamates. So hydroxycernamates are the hydroxy group containing esters. Cernamates, it means that is the esteric form, because in the hemicellulose representation also we represented that with the ferulic acid. So that ferulic acid is the after the de-esterification we may get the acid. So these are the bond together to the hemicellulose part in the form of ester. So this is the polymeric structure of lignin. So this is represented a very complex structure of lignin. So it is not a simple, it should be a very complex material and a three-dimensional representation. So in which the bonds are also present in between the aromatic linkages with the various types of the linkages as I presented with the beta oxygen 4 linkages, beta 5 linkages. Likewise, the different linkages are found in this structure of the lignin. So after the depolymerization of the lignin by the suitable methods, we may get the coniferyl alcohol, para-coumaryl alcohol, and synapyl alcohols. So now we are moving to the main part of the modification process of wood. So wood modification is the process of by using action of chemical, biological, or chemical agents upon the material, resulting in a desired property enhancement during the service life of the modified wood. So here we may do the any action on the wood. So like action of wood may be either chemical, biological, or by using physical agent for getting the desired property of the wood and to enhance the properties of the wood. So the modified wood must contain the desirable properties compared to the raw wood material. The modified wood should itself be non-toxic under service conditions, and furthermore there should be no release of toxic substances during service or at end of life following disposal or recycling of the modified wood. So after the modification process, the end product of wood should not produce any toxic substances, and that should not be hazardous. So in such a case only the modified wood should be made. Next, the modification of the wood process is implemented by the different process like by the action of either physical, biological actions or chemical modifications, we are getting the desirable property of wood. So for the modification of the wood, we can do the four major types of methods: chemical treatments, thermo-hydro, mechanical treatments, treatments based on biological process, and physical treatment with use of electromagnetic radiation or plasma. So in the chemical treatments, we can use the suitable chemical reagents, we modifying the wood and for achieving the desirable property of wood. So in the second process, thermo-hydro method, in which we using the moisture as well as the heat. By using moisture and heat, we are producing the wood with the desirable property. In the third, thermo-hydro mechanical treatments, in which the moisture, heat as well as the force is utilized on wood and modified wood is prepared with the desirable properties and enhanced improved properties for the wood. Third one is the treatments based on biological process. So by using the certain enzymes and certain microorganisms and their actions on the wood to produce the desirable results. Fourth one is the physical treatment with use of electromagnetic radiation. So by using the electromagnetic radiation also, we can produce the wood with the modified wood with the desirable properties. And another part is the chemical modification of wood. So it is very important process here, chemical modification of wood. So chemical modification of the wood is making the reaction between wood with the chemical reagent to form the covalent bond in between reagent and the wood. So whenever the bond is formed in between the wood with the chemical reagent, the properties of wood are improved. So the important active sites of wood is the functional group. As I said in the previous, the cellulose, hemicellulose and lignin part contains hydroxyl groups. The hydroxyl group is the major thing in the case of the chemical modification of the wood. So based upon the hydroxyl group as well as the unsaturation also. Unsaturation means either presence of double bond or triple bond. Whereas in case of lignin, we may found some unsaturation. So unsaturation means presence of the double bonds in the lignin. So those are responsible for making the action on wood for achieving the desirable properties. And here the preferred type of chemical reactions are the hydroxyl group substitutions. So actually here, so number of chemical reactions are possible with alcoholic functional groups, that is the OH. So this is the major OH group is the responsible for the chemical modifications in the wood. After that only unsaturation, to which we can go for the chemical modification, but number of chemical reactions are failing in case of chemical modification of the wood, even though they contains large number of hydroxyl groups, and that may be due to the some of crystallinity present in the molecular in the molecules as well as the intermolecular hydrogen bonding. Those may be responsible for not achieving the chemical reactions with a desirable reagents. So here chemical, what is the chemical that we are using for the chemical modification should not be any toxic and carcinogenic, and also in the wood product, in the end product of wood also, the toxic and carcinogenic nature should not be present. Here we can find some of the chemical reactions of the wood. So the main chemical reaction is the acetic anhydride. So the first modification of the wood is started with acetylation process. Here wood is undergoing reaction with acetic anhydride and producing acetylated wood. Downside what we represented is the acetylated wood, and acetic acid is the byproduct and which can be easily removed because the acetic acid is the easily smelling, and that we can remove either by physical methods like vacuum process methods in which we can remove the acetic acid. Reaction with ketene. Ketene is representation of the C double bond O. So this is the ketene. This wood with a hydroxyl group is making reaction with ketene and producing the same acetylated wood. Here also, what is the product formed is the acetylation wood. That means hydroxyl group is replaced by the COCH3 group. That is the only major difference in between the wood hydroxyl group with acetylated wood. So hydroxyl group is replaced by the COCH3. That group is also called acetyl group. That means that is a keto group. So thereby forming a esteric linkage. Reaction with carboxylic acid. So wood is combining with carboxylic acid. Here carboxylic acid is the COOH. It is the unsaturated carboxylic acid because in this molecule double bond and COOH is present and producing the esterified wood. So this is also another one. Next isocyanates. Here wood hydroxyl groups is making reaction with the isocyanates. Isocyanates are the representation with N double bond C double bond O. These are the isocyanates, and isocyanates are forming the nitrogen containing esters. So here the nitrogen is present along with the OCO NHR. So that means it is called amides actually according to functional group. So next one is the reaction with alkyl chlorides. So alkyl chlorides means alkyl halide, which is a functional group in which is present is the chloride. So wood hydroxyl group is making the reaction with alkyl chloride and producing the representation of ether. So etherified wood is formed. So that means hydroxyl group is replaced by alkoxy group. That means OR group. Reaction with aldehydes. So in the reaction with aldehydes, I represented the reaction with formaldehyde. So wood hydroxyl group making reaction with formaldehyde and produces first one is the here two chemical reactions are found in the after the first arrow mark. What is found is the hemiacetal structure. It is called actually hemiacetal, and again that is also undergoing reaction with the second molecule of formaldehyde and produces the acetal. So in the second final second arrow mark after which you found that is called acetal structure. So that means carbon atom on both sides is bonded by oxygen linkages. So it is called acetal. Next epoxide. So epoxides are also compounds of ether. So that means cyclic ethers are called usually epoxides, cyclic ethers. So this is a cyclic ether, simple molecule we taken here, that is the epoxide. So wood hydroxyl group is combining with this cyclic ether, that is epoxide, and produces the hydroxy ethers. Here hydroxy ethers are found. So here wood on one side is bonded to oxygen atom and another side carbon atom is bonded to hydroxyl group. So these are usually called hydroxy ethers. So hydroxy ethers are formed. Next, reaction with the acrylonitrile. So acrylonitrile is the major component in the polymeric industry. Actually, here wood hydroxyl groups is combining with acrylonitrile and produces the cyanoethylene product. So here both cyanoethylation takes place and to produces ethereal and other side is bonded to cyano group. Next one is the acetylation of the wood. So the major thing in the chemical modification of wood is the acetylation of wood. So because compared to all the chemicals that are using in the chemical modification, acetylation process is very famous process, and in the many countries even the acetylated wood is using. So the history, if you see, the acetylation of wood is first performed by the Fox in the 1928 using acetic anhydride as well as the sulfuric acid as the catalyst. And in this process, the weight gain is observed is the 40% compared to raw material. So the acetylation process due to which the acetyl group percentage is increases by replacing the hydrogen atoms because the molecular weight of hydrogen is only less, that means 1, but acetyl group is having more weight. So thereby the weight gain is observed as the 40%. So here, which means that he decrystallized the cellulose in this process. So due to addition of the sulfuric acid as the catalyst, decrystallization takes place there, but complete decrystallization of the cellulose is not takes place there. Maybe the amorphous part of cellulose may be decrystallized, depolymerized. Used the reaction to isolate lignin from pine wood, and in the same year, horn and soda and tist acetylated beech wood to remove the hemicellulose in a similar lignin isolation procedure. So they are also conducted the procedure for the isolation of the lignin in the 1928. Next, in the year later, that is in 1928, same scientists, they again conducted the experiment by using the pyridine and dimethyl aniline as the catalyst to produce the acetylate, acetyl wood. Acetyl weight gain is again 30 to 35%. After 15 to 35 days at almost 1008 centigrade. So by using that much of the temperature, he observed that the weight gain is much. Okay, sorry, sir. Okay, so this may be 108 degrees centigrade. In 1945, so Turco first demonstrated that acetylated balsa was resistant to decay. In 1946, Turco, Stam and Erickson first described the use of wood acetylation to stabilize the wood from swelling in water. So that means he described the process to stabilize the wood from the swelling of water. Next again, in the 1940s, many laboratories around the world have looked at the acetylation of many different types of wood and agriculture resources. Here, the major process of acetylation of the wood is carried out nowadays. Acetylation is the chemical modification process which the hydroxyl group of wood, either lignin or hemicellulose, actually cellulose part is not that much reacting, reacts with acetic anhydride to form ester. So acetylation process can be done with or without catalyst nowadays. Actually, the process is carrying out without catalyst nowadays by using the 100 to 130 degrees centigrade temperature by using vacuum pressure method to remove the all volatile products like acetic acid in this process. So the acetylation process is still preferable in absence of catalyst because of cost reduction and decreasing environmental pollution. Next, advantages of acetylated wood. Here, the biological durability of wood has been improved. So, biological durability means they can resistant to the attack of fungi, termites, and other insects.